Hello, Sauce here. This is a pre-algebra lesson. We're going to talk about correlation. You can see I have prepared three graphs. These are going to be scatter plots. I've got a t-table of information here. I have two columns. One I've labeled H and one I've labeled with a percentage. We're going to imagine that this data came from an experiment where we measured the percentage of somebody's score on a test. We could imagine it's a math test, but it could be anything. And we're comparing that to how many hours of practice that the person engaged in before taking the test and getting a score. I have an axis here. I'm going to complete the scatter plot. Remember, the best way if we're going to draw a graph by hand, and we already have the information here, is to look to the highest values in the table. In this case, hours, which is a measure of time, has a highest value of 10. I'm going to label the horizontal axis the h-axis, and I'm going to think of h as a measure of time. This is the amount of practice, the hours of practice that somebody engaged in before they took before they scored. And the highest value, 10 here, I'm going to label a tick mark and call that location 10. I'll write it over here. The reason why we first make a tick mark at the highest value is because then we can go back on the line and easily find some other tick marks, like right in the middle. I'm going to put a 5 halfway. If this is the full measure is 10, then halfway is going to be labeled as 5. But I don't need to busy myself making tick marks at every single location. That's unnecessary, and it would take a lot of time to do that. So if I've labeled this axis H, then the vertical axis is going to be my percentage axis, and it's going to stand for, in the real world situation that we're talking about, this is going to be the score that somebody earns. And the highest score that somebody can earn may not be in this table, but if we're taking a standard test, then 100 would be 100% a perfect score. Now the highest score that I have in this table is 95, but I'm going to label my halfway point at 50%, and then in between 50 and 100, I'll go ahead and label 75. You might make different choices when you label your axis and setting up a scatter plot, but you can see I've made some good choices because I know that all of my data is going to fit within the size of this graph. And I've labeled tick marks that will help me out plot these points, but I haven't spent too much time setting up my axis. This is sufficient. Let's plot these points. When H is 1, then the score is 60%. In the context of the real world situation that we were talking about, that means that somebody practiced for 1 hour and took a test and got 60%. Where is that on our graph? Well, 1 is going to be approximately here. And on the percentage axis, I'm going to go beyond 50 to, I estimate, right about there at 60%. It's not going, if we're doing this by hand, it's not going to be absolutely precise, but we're doing the best we can to estimate where these numbers are. I'm going to continue to graph my points. 3 hours is approximately here, and somebody scored an 80% after 3 hours of practice. 4 hours of practice scored 75%, and that's a little bit less. So notice that the points go down a little bit. 5 is 80% again. And I'll quickly finish up approximately 8 up to 90. And after 10 hours of practice, we get the highest score of 95. This completes the scatter plot with the information given. Now, if this was a real experiment, a scientific experiment, to gauge a relationship between hours of practice and the percent score, we would want to have more samples than this 6 here. 6 is kind of a small size of data in a true scientific experiment. Hopefully we would have hundreds of participants in order to get an understanding about how hours of studying can affect the score. But with the data that we have here in the scatter plot, I hope you can see that there is a trend that the more hours that you take to practice, the higher the score you may expect to get. Now, it doesn't have to be a hard and fast rule, because here we can see somebody studied a little less than the person that achieved this score and got a higher score. But there is a general trend. We can visualize the general trend as a line that goes through this data, and I'm going to approximate what it means to go through this data with a line. I've sketched lightly here a line that is sloped up. And when the data points are scattered such that you can generally visibly see a line that is the trend and where those points lie, and that line goes up, then we say this is an example of positive correlation. We say that the data correlates because there's a general trend. In this case, the more hours of practice, the higher your score. Even if it's a slight trend up, we call it positive correlation. Well, let's do this again. I'm going to graph a little more quickly now that we've gone over the basics of arranging a scatter plot. In this case, the axes are going to be labeled H and percent. And percent is still going to mean score if we're imagining a real world situation, a context. But in this case, H is going to stand for the number of hours that somebody has been awake without sleeping. So in our T-table of information, we can see that hours of being awake starts at 12. That would be half a day. Pretty typical for a person to be awake for at least 12 hours in a day. 18 hours is a fairly long day, but not unusual for somebody to be awake for 18 hours. But then 24 hours is a full day of being awake. And if you're awake for even longer, we get to our highest amount of hours awake at 42. That's almost 2 days. I am going to put a tick mark somewhere at the end of this axis for 42. And then I'm going to find the halfway mark, which is at 21, but I don't have hours awake at 21. I've got 18 and 24. So I'm going to go a little bit above halfway and label that 24, and a little bit low and label that 18. And I'm going to put some extra tick marks in here for other times in my table. Percentage again, the highest is going to be at 100. And then I'll find 50 and 75 as reference points. I'm going to graph my information now. This tick mark is 12, and we have a score of 95. 1890, here's 18 and 90 is approximately here. 24 hours awake gets a score of 75. 30 hours awake gets a score of 50. 36 hours awake, and the score is 40, and 42 hours awake, we get another score of 40. Let's look at how these points are distributed on the graph. There does seem to be a trend. I can visualize, very generally, that the points that are graphed line up, not perfectly, but generally enough that I could visualize a line going through the middle of those data points. This line is going down. Its slope is negative. That means it's suggesting that if I am awake for a typical 12 hours, 12 to 18 hours, I'll score fairly high. But the longer that I'm awake, the lower I'm going to score, especially if I'm awake for a very long time without sleep. So in this case, this is an example of correlation because the data seems to line up. But since the data is going down, since the longer we're awake, the lower the score we're going to have, we say this is a negative correlation. This is an example of negative correlation. And finally, we have our third data set. We're going to make a scatter plot. Notice that the highest hour is 3. H still stands for hours. I'll label that tick mark there, and 1/2. The percentage is still the vertical axis, and we're going to put a top percent of 100, halfway at 50, and then in between at 75. The context in this third example is a little bit different. In this case, H is still an amount of time, hours. But we're going to think of this as the number of hours in a day that somebody played basketball. So when we say 3 hours, we mean a person played 3 hours of basketball that day. And they took a test and got a score. Plotting the data, if in this case the 0.080 means that no basketball was played and a score of 80 was achieved. 1/2 hour, a score of 55. Now where is 1/2? I'm going to put a couple of tick marks here and label this 1. 1/2 hour is here and a score of 55. After 1 hour, we have a data point at 95. That's a very good score. And we have a second person who must have played for 1 hour and scored 65. Finishing up, after 2 hours played, let's imagine somebody scored 85. And 3 hours played, let's imagine somebody scored 70. And we take a look at our scatter plot. It's difficult to imagine drawing a line that shows a trend in this information. I could draw one like this very generally, but the points would be very far away from my line. I could also just as well draw a line that went up slightly. Again, if I did, the data points would be fairly far from my line. So in this case, when I'm confused where to draw the line, I shouldn't. In this case, the points are so scattered about, there doesn't seem to be a trend. That's especially seen in the place where two different people playing the same amount of basketball scored wildly different on the test. This is suggesting that there is no correlation. There does not seem to be a relationship in this data. And we might conclude, if we were to do this, collect a lot of data, that there's no relationship, there's no trend between playing basketball and scoring well on something like a math test. They're not correlated.